Hi everyone, welcome back to my YouTube channel. Today's video we are going to discuss about the construction and operation of the PNP transistor, and end of this video you will get a clear understanding about construction and operation of the PNP transistor, its characteristics, properties, advantages and disadvantages, some important formulas related to the PNP transistor. So let's get into the video. So before getting into the details, let's first understand why the transistor is called bipolar junction transistor and what is the reason behind it. So because it uses the both type of charge carriers, majority charge carriers as well as the minority charge carriers. So for its operation, so because of using the both types of carriers, its operation, the device is called bipolar device. And since it contains the two types of PN junction, this is the reason why the device is called bipolar junction transistor. And now the construction of PNP transistor. Here I am dividing the construction of the PNP transistors into the two sections. This input section and output section. So you see the input section here, the PNP transistor, right? So according to PNP transistor, here the emitter is P, base is N, and collector is P. So here the P-type emitter is connected to the positive terminal, and coming to base is N-type, right? So N-type is connected to the negative terminal. So here it is comes under the forward bias, and here the voltage is VEB. So why it is called VEB means that is the voltage in between the emitter and base. That's why the input voltage is VBE. And now coming to the output section. Here the output section is collector is P type and base is N type, right? So the base is connected to the positive terminal and collector of the P type which is connected to the negative terminal. Means here the output section which comes under the reverse bias, and the voltage is VEB means voltage in between the collector and base, that voltage is called VCB, which comes under the reverse bias. Under this condition means when the input is forward bias means the emitter base junction is forward bias and collector base junction is reverse bias, and only the transistor will act as the active region. So why the transistor works under the active region as the amplifier means because of the linearity. And here are the some important point that you should remember. So when the emitter junction is under the forward bias and collector junction is under the reverse bias, then the transistor is in the active region and which will act as an amplifier. And when the both junctions or comes under the forward bias, it is comes under the saturation region and which will act as a on switch. And third point is when both junctions are comes under the reverse bias, then the transistor which is comes under the cutoff region and which will act as a off switch. And when the emitter junction is for reverse bias and collector junction is forward bias, then the region is inverted and it will not conduct. So these are the three regions which a transistor will works. Now we will see the working of PNP transistors. In a PNP transistors, the base emitter junction is forward bias and the collector base junction is reverse bias. Because of this biasing arrangement, as we know, the transistor will works under the active region. So now we will see the working of PNP transistor. So first I want to give the names to this. This is N, P, N, and here this collector, and this is the base, and this is emitter. So here there are the two conditions that should be satisfied, that transistor should act as an amplifier. Means here two conditions should be satisfied. The conditions are the emitter junction should be forward bias and the collector junction should be reverse bias. Under these condition only the transistor will act as an amplifier. So here the p-type which having the positive, and here the n-type which is having the negative polarity, and here the p-type is positive. Now I want the emitter junction should be forward bias. Now I want to give the biasing in between the base and the emitter. The biasing like that is positive and positive. So which comes under the forward bias, and the voltage is VEB. Why this voltage is the voltage in between the emitter and the base. And now coming to the output section. So output section means the collector junction should be under the reverse bias. Here I have the P type which is comes under the positive, and now I want to do the biasing. So P type having negative, positive. So which comes under the reverse bias, and the voltage is ECB, the voltage in between the collector and the base. So this is the biasing. Under this condition only, transistor which will act as a amplifier. Transistor which will act as a amplifier. Now we will see the working. So all of you know that in the P type, the majority charge carriers are holes. And coming to N type, in N type, the majority charge carriers are electrons. So when the junction, when it is in under the forward bias, here the electrons and holes will attract towards each other and recombination will be takes place. Means the electrons and holes which move will attract towards each other. Here the main thing you should remember it is base is very thin, it is very lightly doped. So because of these two reasons, here only small little amount of electrons and holes will recombine each other, and remaining all holes are moved towards the collector region. Because of the these two regions. Why? Because it is very thin and the lightly doped. So after coming to the this is the so after recombination, the remaining all holes which moves towards the collector. So here the collector is under the reverse bias. So with having the high electric field, due to the electric field which are not recombined in the P type, that all holes are pushed into the P type means collector. So here the current conduction due to holes. So this is the reason why in PNP transistor the current conduction due to holes, and this is the working of PNP transistors. Now we will see the properties of PNP transistor. First property is voltage rating. Means it has the maximum voltage ratings and has the current ratings, and gain which is the gain is current gain, and the power dissipation, frequency response, and temperature range. So these are the some properties which are related to the PNP transistors. Characteristics of PNP transistors are common emitter gain, saturation region, cutoff region, active region, linearity, and base control current. And now coming to advantages, disadvantages, and applications of the PNP transistor. And first we see the advantages. Advantages are these PNP transistors are mainly used in the high power applications, and advantages is by using this we can amplify the signals and the switching purpose. And coming to disadvantages, the disadvantages is it has the less mobility, means because of the holes having the less mobility when compared to the electrons. So the work operation is slower when compared to NPN transistors. And applications are switching, amplifiers, power circuits, and sensors. These are the applications of PNP transistors. So that's it for today's video. In next video, we will see the NPN transistor construction and working. Both are same, but there is a little difference between the NPN transistor and BNP transistors. So in next video, we will see the working and construction. And if you like the content and if you like the video, don't forget to subscribe my YouTube channel and share this video with your friends. Thank you for watching and see you in the next video.